Now today we are going to discuss the wave particle duality of light and the Broglie theory. Now if you consider the photon picture of radiation, then we have E equal to h nu, that is energy of photon, and also for relativistic particle E is equals to mc square. Now in these equations, this kind of equation can also be written for photon, that is the relativistic mass. Here energy and mass are the particle properties, whereas frequency is the wave property, and therefore we say there exists wave particle dualism in light. If you study the entire electromagnetic spectrum, then you will find that lower frequency range has higher wavelength, whereas higher frequency, that is X-ray and gamma rays, has a very lower wavelength. If you say one radio frequency wave can be spread like this, it can have a wavelength of few meters, whereas the wavelength of an X-ray is 1 angstrom. It is so smaller that even a point if you try to draw, it is much larger than the 1 angstrom. Therefore, here on this particular wave, at certain particular center the energy is concentrated, whereas at this higher frequency X-rays, at one point the entire energy is concentrated. And due to this, we say under these conditions light exhibit particle nature, whereas under these conditions light exhibit wave nature. So Louis de Broglie has something other in his mind. He says that if very short wavelength light can be treated as particle, then why not a very tiny particle, that is particle or subatomic particles, electron, proton and certain smaller atoms, hydrogen, helium, why they cannot have certain wave-like nature? And according to de Broglie, if we consider a particle of mass m moving with a certain velocity, then according to de Broglie, this moving particle can exhibit wave-like nature, and the wavelength associated with this particle is given by h upon mv, where m into v, mass into velocity, is the momentum. Therefore, we can write lambda is equals to h upon p. So these two expressions which I have written are called as de Broglie wavelength of the particle if it is moving and exhibiting wave-like nature. So whenever a particle is moving, according to de Broglie, one can associate a wave having wavelength lambda is equals to h upon mv with it, where h is Planck's constant, m is the mass of the particle, and v is its velocity. Or we can write lambda is equals to h upon p. This wavelength is called as de Broglie wavelength or matter wave. इसे हम क्या बोलते हैं? de Broglie wavelength. और ये जो wave है जो particle के साथ में associate होगी, this wave is called as matter wave. And this hypothesis is called as de Broglie hypothesis or theory. In support of his hypothesis, he says that his theory is more significant for subatomic or microscopic particle, whereas it is less or least significant for the macroscopic or larger object. To illustrate this, let us consider a ball. Case number 1, we are considering a ball having mass, let's consider 1 kilogram, and it is moving with a velocity of 100 meters per second. Then de Broglie wavelength associated with it will be lambda is equals to h upon mv. It will be 6.3 10 to the power minus 34 divided by mass is 1 into 10 to the power 3. It will be 6.63 into 10 to the power minus 37 meters. The wavelength associated with a ball which might be of 1 kg having a very large velocity of 100 meters per second, if you associate the wavelength of de Broglie wave is very small, 10 to the 10⁻⁻37 दैट कभी भी आपको वेव दिखेगी नहीं। वो जो बॉल रहेगा उसका साइज ही इतना बड़ा रहेगा कि उसके साइज के अंदर में ऐसे lakhs billion trillions of wave can be associated. So for such kind of an object never one can get wave like nature. So macroscopic or larger object cannot exhibit wave like nature. Why? According to the Broglie theory, the wavelength associated is very much smaller than its size. Whereas if we consider, discuss the second case, a microscopic particle like electron, अगर से आप इलेक्ट्रॉन को कंसीडर करते हैं जिसका मास रहता है 9.11 ×10⁻31 kg. Let us consider, मास आपने लिया, velocity of electron is again 100 meter per second. Then the de Broglie wavelength associated with it will be lambda is equals to h upon mv. It will be 6.63 ×10⁻24 divided by 9.11 ×10⁻31. You will find that this lambda is equals to how much it will be? Now 6 divided by 9. रेडी? इसको अब जब यहाँ से डिवाइड करेंगे और उसको आप एक बार लिख सकता हूँ मैं 66.3 into 10 to the power, इसको मैंने कम कर दिया -33, नीचे से आया 10 to the power +31 and it is divided by say 9.11. तो ये 31 और ये 33, यहाँ से आपको मिलेगा 10 to the power -2. इसको जब आप वर्कआउट करेंगे तो it will be 7.2 something. It will be meter. So you will notice that the wavelength associated with a particular electron moving with 100 meter per second, it is 7.2 10 to the power -2 meter. It is very large compared to the size of electron. If the size of electron approximately will be 0.667 angstrom, it is 0.667 into 10 to the power -10 meter. You can see the size of an electron. And what is the value of the Broglie wavelength? 7.2 10 to the power -2. It means that इस वेवलेंथ के ऊपर में जो आ रही इलेक्ट्रॉन के साथ ऑसिलेट करने पर more than 10 to the power 8 such de Broglie waves can be, इसके साइज के ऊपर में जो साइज है, जितने साइज है जो वेवलेंथ आ रही है उसमें 10 to the power 8 इलेक्ट्रॉन आप एक के बाजू में कैसे रख सकते हैं, क्योंकि इलेक्ट्रॉन का साइज छोटा है. Under this condition, de Broglie says you cannot say that the wave-like nature is not significant. If such kind of particles, if they are moving, they exhibit the wave-like nature. So it is a radical departure from the classical theory. According to classical theory, particle है वो localized रहेगा, वो हमेशा particle nature को exhibit करेगा. लेकिन de Broglie का बोलना ये है कि अगर वो microscopic particle है, if वो certain velocity के साथ में move कर रहा है, जब वो मूव करेगा तो एट द टाइम आप उसके साथ में वेव एसोसिएट कर सकते हैं और वो जो वेवलेंथ आपको मिलेगी वो वेवलेंथ आप यहां देख सकते हैं. इट इज मच लार्जर देन द साइज ऑफ द एटम एंड देयरफॉर सच काइंड ऑफ माइक्रोस्कोपिक पार्टिकल मूविंग विद सर्टेन वेलोसिटी कैन एक्सिबिट wave-like nature, and therefore it is said that de Broglie theory is significant for microscopic particle and not significant for larger or macroscopic. So, if question is asked in the initial examination that what is the Broglie hypothesis, explain its significance, we have to write that every moving particle can associate with a wave in wavelength, lambda is equals to h upon p or lambda is equals to h upon mv, right? Where h is Planck's constant, m is the mass, m is the velocity, p is the momentum. And for two examples you have to set for a ball which is a larger object, जिसको अपनी आंखों से देख सकते हो, बॉल का आपने मास ले लिया, उसकी वेलोसिटी ले ली, वेवलेंथ आपने निकाली, जो बहुत ही छोटी है उसके साइज से, इसलिए कभी भी वेवलेंथ नेचर के लार्जर ऑब्जेक्ट जो है एक्सिबिट नहीं करेगा. वेयरएज अगर सब माइक्रोस्कोपिक पार्टिकल ऐसा एटॉमिक पार्टिकल्स लाइक इलेक्ट्रॉन प्रोटॉन इनको आप कंसीडर करते हैं, तो एट द टाइम द वेवलेंथ कम्स आउट will be much larger than the size of the particle, and therefore such kind of microscopic particle can exhibit or reveals wavelength nature. The next is we will try to find the expression for de Broglie wavelength of an electron if it is accelerated by a particular potential difference. तो हम यहाँ निकालेंगे expression for de Broglie wavelength of electron. De Broglie wavelength of an electron accelerated by a potential difference of कैपिटल V volts। एग्जाम में पूछ लिया वाला एकदम रेगुलर क्वेश्चन कि अगर से आप किसी इलेक्ट्रॉन को एक पोटेंशियल डिफरेंस V के साथ में एक्सलरेट करते हैं तो उसके साथ में जो डी ब्रोगली वेवलेंथ एसोसिएट होगी उसके लिए आप एक्सप्रेशन को फाइंड कीजिए। इसके लिए हम यह कंसीडर कर रहे हैं कि एक इलेक्ट्रिक फील्ड है। इस इलेक्ट्रिक फील्ड को ऑब्टेन करने के लिए आपने क्या किया, आपने यहाँ से एक पोटेंशियल डिफरेंस लगाया दैट इज V वोल्ट का। ये आपकी नेगेटिव प्लेट के ऊपर आपने इलेक्ट्रॉन को रखा और उसके बीच सामने में ओपनिंग कर दी। जैसे ही आप यहाँ पर एक स्विच लगाएंगे उसको आप क्लोज करेंगे तो दोनों प्लेट्स के बीच में पॉजिटिव प्लेट है नेगेटिव प्लेट है। यहाँ पे पोटेंशियल डिफरेंस भी सेटअप होगा, चार्ज ऑफ इलेक्ट्रॉन है E। जैसे ही पोटेंशियल डिफरेंस भी सेटअप होगा इलेक्ट्रॉन जो रेस पर था वो एक हायर वेलोसिटी के साथ में यहाँ से बाहर जाएगा और यहाँ से बाहर निकलेगा विद वेलोसिटी V, राइट। In this case, the potential energy of electron is equals to E into V. You know this. The definition of electric potential and potential energy is E into V. This is the equation number 1. Right? If due to this potential difference, electron gets the velocity of V volt, then electron will start moving with a kinetic energy of 1 by 2 mv square, the ratio m is mass of the electron and v is the velocity with which it is moving, such that this is equation number 2, such that एक केस कैसे हुई कि यहाँ पे जो भी पोटेंशियल एनर्जी उसने गेन की जब वो स्टार्ट हुआ मूव करना तो वो पोटेंशियल एनर्जी काइनेटिक एनर्जी में कन्वर्ट हो जाएगी, such that your kinetic energy is obtained from potential energy and therefore we write 1 by 2 m v square is equals to ev, therefore m into v square is equals to twice ev, or I am writing m square v square is equals to twice em into v. This is equation number 1 or equation number A, you can give it. Now according to de Broglie theory, what is happening here? According to de Broglie theory, see very properly, it is very simple. De Broglie theory, we know that lambda is equals to h upon mv, right? Lambda is equals to h upon mv. This is equation number B. Now from equation A, you can see it. From equation A, what did we get? M into V whole square is equals to twice E m into capital V. Therefore, mv is equals to under root twice E m into capital V. ये आ गया equation number C. From B and C, what did I get? From B and C, what I get? Lambda is equals to h upon mv का वैल्यू कितना आया? Under root twice E m into capital V. So this is the expression for the de Broglie wavelength associated with the electron if it is accelerated by a potential difference of V volts. Now, in this equation number say D, यहाँ पे equation number D आया. If in equation number D, if we put here in this equation mass of the electron 9.11 10 to the power minus 21 kilogram, then charge of the electron 1.6 10 to the power minus 19 coulomb, and one more thing is that two things are we have put that Planck's constant h is equals to 6.63 times to the power minus 34 joule second. जब ये सारी चीजें आप यहाँ प्लेस करते हैं तो by equation number D, what did we get? Lambda is equals to what I am writing 6.63 into 10 to the power minus 34 divided by under root 2 as it is 1.6 10 to the power minus 19 into mass के आपके पास में 9.11 10 to the power minus 31, इसको ब्रैकेट में लिख दिया, यहाँ लिखा under root 1 divided by under root V. If you work out this complete thing, you will find it will be lambda is equals to 12.26 into 10 to the power minus 10 divided by under root V, and it will be in meters, and we know that 10 to the power minus 10 is Armstrong. Therefore, lambda is equals to 12.26 divided by under root V. It is in Armstrong. तो रेडीमेड आपको एक्सप्रेशन यहाँ पे मिलता है de Broglie wavelength associated with an electron if it is accelerated by a potential difference of V volt is 12.26 divided by root V into Armstrong. एग्जाम में कई बार 3-4 मार्क के लिए ये क्वेश्चन पूछा हुआ है, you can write this very properly. बहुत सिंपल सा है. Let us consider an electron in this way is accelerated by a potential difference of V volts. ठीक है. Initially, when potential difference is applied, the potential energy is equal to B. If electron starts moving with velocity v, then its kinetic energy is 1 by 2 mv square. Such that potential energy is converted into kinetic energy. We work out for m square v square equal to this much. Then according to de Broglie theory, lambda is equal to mv. mv का वैल्यू हम यहाँ से डालेंगे, ये मिलेगा. यहाँ पर h, e और m का वैल्यू डाल के सॉल्व करेंगे तो आपको मिलेगा लैम्डा फॉर इलेक्ट्रॉन is 12.26 divided by root v into answer. So this is an expression you should practice. Now कुछ results इस expressions के मैं आपको बता रहा हूँ. ये हो गया expression for de Broglie wavelength of an electron accelerated by potential difference of v volts. ठीक है. अब अगर से यही क्वेश्चन आपको थोड़ा चेंज करके पूछा जाए कि फाइंड एक्सप्रेशन फॉर de Broglie wavelength of a charged particle having charge q accelerated by v volts. क्वेश्चन को मैं चेंज करूं. कैसे चेंज किया? अब आपके पास में चार्ज पार्टिकल दे दिया गया, उस चार्ज पार्टिकल के ऊपर का जो चार्ज है वो q है, उसको एक्सेलरेट कर रहे हैं आप एक पोटेंशियल डिफरेंस v वोल्ट्स के साथ में. So at the time in place of this you have to put the charge particle q is equal to question बराबर. Then initially its potential energy is q. If m is the mass of the charge particle तो आप इसको लिखेंगे यहाँ पर m. Mass of the charge particle ये डिफरेंट हो जाएगा अभी इलेक्ट्रॉन से. Such that kinetic energy equal to potential energy. तो यहाँ पे आपको मिलेगा q, यहाँ पे भी आपको मिलेगा q और यहाँ पे भी आपको मिलेगा this q. इसको सॉल्व करते जाएंगे, जहाँ पे e आया वहाँ पे आप लिखेंगे q, जहाँ पर भी e आ रहा है वहाँ पे आप लिखेंगे q और फाइनल एक्सप्रेशन आपको मिलेगा lambda is equal to h divided by root twice q into v. It is a generalized formula for any kind of charge particle which is accelerated by v volts. Got the point? Which is accelerated by v volts. This is one. समझ में आया? तो आपको ये सेकंड क्वेश्चन लिखना है. पहला क्वेश्चन क्या था फॉर इलेक्ट्रॉन, सेकंड क्वेश्चन क्या था फॉर एनी चार्ज पार्टिकल. नाउ लेट अस सी few more things out of it. यहाँ से कुछ और बातें आपको मैं साथ साथ बताता चलूं, फिर बाद में हमारा एक बड़ा सा टॉपिक है डेल्यूशन जनरल एक्सपेरिमेंट, वो हम यहाँ से करेंगे. अब एक है मेरे पास में एक क्वेश्चन और एग्जाम में एक बार पूछा हुआ था. If kinetic energy of a charged particle, if kinetic energy of a charged particle is E, find its de Broglie wavelength. Find its de Broglie wavelength. ये एक और न्यूमेरिकल्स वगैरह सॉल्व करने के लिए छोटा सा एक्सप्रेशन है, वो आपको ध्यान से समझना है. एक एक स्टेप के लिए बहुत इंपॉर्टेंट है. लेट इसको सोल्यूशन बता रहे हैं. m is the mass of the charged particle, mass of charged particle, right? q is charge of the particle. जो पार्टिकल है उस पे जो चार्ज है वो है q. Then E is equals to kinetic energy, which will be equal to 1 by 2 m v square, where v is the velocity. Where is the velocity? What is v? Where v is velocity of the particle. Then I can write E is equals to 1 by 2 mv square, such that mv is equals to twice e mv square. Okay, then m square p square multiply कर देंगे m से twice m e, equation number 1. Now according to de Broglie, what is happening? According to de Broglie theory क्या मिलता है? lambda is equals to h upon mv. इक्वेशन नंबर 2. 1 को देखो, 2 पे देखो, mv की जगह पे लिखेंगे. therefore यहाँ से आपको क्या मिलेगा? therefore यहाँ से क्या मिलेगा आपको? lambda is equals to, यहाँ पे किसके पावर लिख देता हूँ मैं, m into v is equals to under root twice m e. therefore lambda is equals to h divided by under root twice m e. this is another expression to find the wavelength, de Broglie wavelength of a particle which has kinetic energy. तो ये छोटा सा एक्सप्रेशन है, ये भी आपको याद रखना है. न्यूमेरिकल सॉल्व करते हुए हमारे आने वाले थर्ड यूनिट के अंदर में हम इसको यूज करते हैं. तो यहाँ पर मैंने 2-3 क्वेश्चंस कवर किए हैं. पहला क्वेश्चन था व्हाट इज de Broglie theory. व्हाई इट इज सिग्निफिकेंट फॉर माइक्रोस्कोपिक पार्टिकल। दूसरा क्वेश्चन था फाइंड द डी ब्रॉगली वेवलेंथ एसोसिएटेड विद एन इलेक्ट्रॉन इफ इट इज एक्सेलरेटेड बाय v volts, and you have to change that expression for a charged particle accelerated by v volts। तीसरा क्वेश्चन था फाइंड द डी ब्रॉगली वेवलेंथ ऑफ ए पार्टिकल हैविंग काइनेटिक एनर्जी E। ये छोटे छोटे एक्सप्रेशंस है, आपको इसका अकाउंटेबिलिटी रखना है, इसको प्रैक्टिस करना है और ध्यान में रखना है। न्यूमेरिकल सॉल्व करने के लिए ये बहुत ज्यादा यूजफुल है। थैंक यू फॉर वॉचिंग।